Okay, hey guys, this is question 2 for tutorial 5. I'll say right at the bat that you're going to be graphing. Your graphs you're making for this are a little bit different than those you've made for your homework, and you should not do this for your homework. The only reason why the professor has this here, I believe, is because it makes it a lot easier to grade, and it's also it's a lot more consistent amongst people. Yeah, there are reasons why he's using this here, but for generally you'll want to draw a separate frame for each section. This is a frame, as is stated in your problem. I'm not going to go into how to find your reactions very quickly. I'm not going to go into too much detail with this one, actually, even though this is the one that was worth the most points. I will tell you that don't plug in these numbers. Like I said for the last example, do not plug in these numbers until the very end, because it's very easy when you start plugging in numbers to make mistakes. And once you start plugging in numbers, it's very hard to fix your work. If you leave it in terms of variables, you can just change the variable very quickly without having to worry about without having to recalculate everything. So the first thing I do is that whenever I see these things here, things that are placed at an angle, I always turn them into vertical and horizontal components. So this is 2p, and there's also a 2p acting this way. I didn't mean to cross out the 45 degrees, but there's 2p acting down and to the left. Yeah, that's pretty much it. I don't want to go into, I can't give you the solutions directly on here, but it's very similar. The reactions are very similar to the last problem. The frame itself the idea of the frame is similar to your homework. What I might do is remember that let's look at axial force, for example. Your axial force is going to be, your axial force is going to be constant in here, and yeah, your axial force, it's going to be compression in here, and it doesn't matter what your sign convention is for compression. I usually label compression as negative, but you just need to write down if this is your, I'll show you that your axial force is going to be constant in here because you have nothing that acts axially from A to B to C. You have something that acts in tangent to it. You have something that acts horizontally. We have nothing that acts axially. So your thing is going to be constant through here. And I'll say that this is negative. So I will say that this is compressive. And you just need to find the magnitude of this. It says draw to scale, but include all the magnitudes. So this will go down to negative AY, or this will go down to AY, depending on what your value is for AY. For AY is negative, and this will be negative. For AY is positive, this will be positive. Yeah, and that's pretty much it. Your axial force and your shear force change, but the solutions to the last homework problems are posted, so you can use those as an example. I can't go giving you, there's really not much I can do here without just giving you a solution, because I already showed you how to find reactions in a previous video. So yeah, I'm gonna make, we only have 3 homework problems, but I'll try making a fourth video on just drawing graphs, because a lot of you seem to be struggling with that. Or at least a lot of people that came to my office hours were struggling with that. So yeah, so that'll be, look for that video if you need help with drawing these graphs. But yeah, definitely stop by my office. We can, or not just my office, but Naveed and the professor have office hours on Wednesday, this Wednesday and next Wednesday before the exam. We'll yeah, we'll try to work something out. If you want to schedule an appointment, just feel free to email us, but you definitely need to get comfortable with drawing these moment shear and axial force diagrams. So they're very useful. All